Okay, I'd like to show you how to add or subtract radicals. Well, when it comes to adding and subtracting radicals, what exactly does it mean when there's a number in front? Well, that number means that there are two square root of 24s. And what this is saying is it wants to take away 3 square root of 12s. And then it wants to add 2 square root of 27s. Well, to me, I'm like, I can't do any of that because I only have 2 square root of 24s. How do you take away 3 square root of 12s if I don't have any square root of 12s? Well, and then this is kind of what I'm thinking of. It's kind of like you're saying 2x minus 3y plus 2z. You cannot combine them because they're all different variables. In this case, they're all different types of roots, so you cannot combine them. But what I'm noticing about 24, 12, and 27 is that most of them can be simplified further. Now, I like to use the cake method, so let's look at 24. I'm going to kind of do that over here. I'm going to take 24, and I'm going to try to simplify it with the cake method. I'm going to divide it by 2, and I get 12. I'll divide it by 2 again and get 6. I'll divide it by 2 again and get 3. So there's the prime factorization of 24. And if I'm taking the square root, anytime I have a pair of values, that's a perfect square. So I get to take out that 2. Well, since there's already a 2 there, you just get to multiply the 2. So what 2 square root 24 reduces to is 4 square root of my leftovers. 2 times 3 is 6. All right, let's go ahead and try to simplify the next one now. I'm going to do the next one over here, 12. I can simplify 12, same type of thing. I'm going to go 2 goes into 12 6 times, and then 2 goes into 6 3 times. I have a pair of 2's, which means I've found a perfect square, so I'm going to take out that 2. Now, since there's already a number there, we're going to multiply it. Negative 2 times 3 is negative 6. But this time left over in my square root is a 3. So I have negative 6 square root of 3. Now I still actually can't combine these because now I have 4 square root of 6's and I'm taking away 6 square root of 3's. Well, a square root of 3 is not the same thing as a square root of 6, so there's really nothing I can do here. But let's still simplify this one and just see if there's anything that we can do. So I'll bring 27 over here and I'll reduce 27. This time I'm going to divide it by the prime number 3. 3 goes into 27 9 times. 3 goes into 9 3 times. So there's the prime factorization of 27. And sure enough, there's a pair of 3's. I found a perfect square, so the 3 gets to leave. Since there's already a 2 there, you multiply them. 3 times 2 is 6. And I have a remaining amount of 3. Well, now that everything is simplified, let's see what we have. Again, we have 4 square root of 6's. We don't have any other square root of 6's. So this can't be anything else. But what we're saying here is we have negative 6 square root of 3's, and we want to add 6 square root of 3's. Well, guess what? They're both square root of 3 values, so you can combine them. And it just so happens to be negative 6 and positive 6. So actually, these cancel each other out. And my final answer is 4 square root 6. So the biggest thing I want you guys to see here with adding and subtracting radicals is that you can add or subtract them as long as they're the same type of radical. They have to be the exact same type as in square roots, but they also have to be the same kind of number on the inside. Sometimes they cancel out, and sometimes you just have to write them next to